Welcome, fellow chemists, to the second video on the reactions of the alkynes. With 4 alkyne videos remaining after this one, please reach out to me via email, social media, or in the comments with suggestions for future videos. Today we will encounter the radicals. Definitely watch the video on the reaction of radicals and alkenes before watching this. Seriously, pause this, click the link in the card or description and watch. I'll wait. You're back? Good. I will keep this one fairly brief as the explanation you need is in that alkene video. The big takeaway with radical reactions is that, compared to typical addition, the regioselectivity is now completely reversed. By now you should feel real familiar with the 3 acts of radical reactions: initiation, propagation, and termination. The initiation steps begin when the peroxide is split into alkoxyl radicals by light or heat. It continues when the alkoxyl radicals then splits the hydrogen bromide and forms a bromine radical. The bromine radical reacts with the alkyne and forms an alkenyl bromide radical. This radical then reacts with hydrogen bromide and produces the expected product. Crucially, at the end of the propagation steps, the original bromine radical is created, and so the process continues. Remember that isomers of alkenes can be identified pretty easily. In this case, we have the trans version with both hydrogens on opposite sides. This corresponds with the E version based on priority. Of course, if bromine ends up in the other location, we have the cis or Z version as both hydrogens or priorities are on the same side. The termination steps involve the reaction of 2 radicals, the simplest being 2 bromine radicals forming bromine molecules. A bromine radical can react with the alkenyl bromide radical, forming a dihalide product, and finally 2 alkenyl bromide radicals can react to form an even larger dihalide and diene product. As the radicals disappear, the reaction comes to an end or terminates. So the reaction can result in a cis-Z or trans-E haloalkene. Give it a go with but2-ine and draw the major product and name it too. There is no guarantee that you would draw the product the same as I would, at least at first glance. All 4 of these structures are the same cis-Z isomer. Likewise, the same is true for these 4 structures, which are all the same trans-E isomer. They appear different, but the bonding and structures are identical. Now, is it any different with the terminal alkyne? Try with but1-ine. Once again, we can draw 4 seemingly different but identical structures for the cis-Z isomer. Unsurprisingly, this is true again for the trans-E isomer. Like before, in each case they appear different but are identical. In summary, just like the alkenes, only hydrogen bromide undergoes radical addition to alkynes. If the alkyne is terminal, the end result is a primary bromoalkene, which could be cis-Z or trans-E. If the alkyne is internal, the end result would be a secondary bromoalkene, which could also be cis-Z or trans-E. Coming up, we are going to look at the hydration of the alkynes. Thank you very much for watching. If you enjoyed this video, please like and subscribe as I have more in development. With hydration on the horizon, check out the certainly similar reactions for the alkenes before the one with alkynes is posted in a couple of weeks.